Okay, so in the first one here, you're given the logistic differential equation. Is number of DVD players in U.S. homes. P is in millions. T represents a year since 2002. Here it is. Okay, so if we go ahead and look at this, it gave you that in 2002, P sub 0 was 7. If you look here, carrying capacity is 200, I'm sorry. This is R over K. So in order to find K, we're going to multiply this by 200. And what happens is the decimal moves over twice, and then you double this, so you get 0.36. A is equal to K minus your initial divided by your initial. So that's going to be 200 minus 7 over 7, which gives me 193 over 7, which does not reduce. Okay? Alright, so from that we can come up with our equation, which is then P of T is equal to 200 over 1 plus, I'm going to reduce this down a little bit, 193 over 7 e to the negative 0.36 t. There's a decimal in there. Okay? Alright, so part C, I want you to remember we're taking the limit of that function. And it's going to, remember it looks, ooh, whoops. And if you remember, that's logistic curve, so it eventually approaches the carrying capacity. So we would say the limit as t approaches infinity of P of T is going to equal 200, because that's your carrying capacity, but we've got to include units. The reason for that is it always approaches its carrying capacity, and that's going to be million DVD players. Okay? Alright. Number 2, now we're going to do the same thing for the derivative. What I want you to think about this is eventually the slope is equal to 0. In fact, if you go either direction, the slope is equal to 0. Okay? So this is going to equal 0, and including units, that's going to be what? Million DVD players per year. That's the rate of increase at that point. Okay? And then the last one is E is how fast is the population growing when 80 million homes have DVD players. So we're going to go back and use our differential equation, but we know that P is going to equal 80. Okay? So if we go back down here, and we're going to say we're looking to find the PDT when T is equal to 80. And that's going to be 0.0018 times 80 times 200 minus 80. And if you whip that out on your calculator, I believe you get 17.28, and our units on that are million DVD players per year. So you got to make sure you put it in the context. Okay? And then F says compute the estimated number of DVD players in 2013. Well, we know that T is equal to 0 corresponded to 2002. So 2013 corresponds to when t is equal to 11. So I really need to go find p of 11, which is going to be 200 over 1 plus the 193 over 7 e to the negative 0.36 times 11. Okay, if you carefully type that in, you got to make sure you put parentheses around this and parentheses around that. Okay, you get 136.096, and that's million DVD players. Okay, and our last one, whoops. Ooh, don't need Twitter on there. Alright, go away. Alright, I'm done. Okay, last one. I don't know why this isn't going away. No, don't allow. Alright, let's look at the last one. It's not going away. Not while I'm on this one. Alright, so if we look at, I just got my split screen, that's all. There we go. Now let's get back to this. Alright. So now it says if the market is considered saturated when 90% of the target households have a DVD player, what year does this occur? Well, 90% of K is 180,000. So we're trying to see when this function is equal to 100, or is equal to 180, I'm sorry, and that's 193 over 7e to the minus 0.36t. Okay, I'm going to cross multiply, and then we get 180 plus, if I do 193 times 180, I get 34740 over 7 e to the negative 0.36t, and that's going to equal 200. Okay, so my next two steps would be is I'd subtract the 180, and then I would first of all I would subtract the 180, and then I would go multiply by its reciprocal, and so when I do that I get 20. It's 20 times the reciprocal, which is 7 over 34740 is equal to e to the negative 0.36t. Okay, when I do a solve for that, we end up getting t is equal to 15.317 years. Well, you remember 0 was represented 2002, so I have to add 2002 to that, and I get that it's 2017.317. So if you really think about it, that's probably right around in April or late March of 2017. Okay, hope this helps. Thanks. Bye-bye.